Hi everyone, this is Dr. V.S. Nishok, Assistant Professor, EC Department, SNS College of Technology. Here we are going to see about the topic named Dynamic CMOS Design. Till now we have seen about static CMOS logic, that is various logics, namely CMOS logic, pass transistor logic, transmission gates, and pseudo NMOS logic. Comparing to that one, now from this video onwards, we are going to see the various logics comes under the category dynamic CMOS design. So here in this video we are going to cover the dynamic circuit logic and its modes of operation like pre-charge and evaluate, and we are going to compare the CMOS circuit under the two different modes and its advantages and its issues. Okay, we are starting with the introduction. So here we are seeing in the left side diagram, we are seeing the general CMOS NOR gate, 4 input NOR gate with A, B, C, D as its input, which is having 4 NMOS transistors connected parallelly in the pull down network and 4 PMOS transistors connected seriously in the pull up network. So that is a static CMOS logic. So in the right side, if you see, you are having one PMOS transistor above, and the input given is nothing but the clock signal, that is represented as a phi. The same input is given to the foot, that is nothing but the NMOS transistor. So here in between the pull down network, that is in the top of the pull down network and at the bottom of the pull down network, we are connecting one PMOS and one NMOS with the individual clock signal as the input. So in the pull down network, as usual, based on the number of input signals, we are connecting the n number of transistors. So that is the case for dynamic logic structure. So here we are having, in the dynamic circuit, we are having two modes of operation, that is called as pre-charge mode and evaluation mode. So in the pre-charge mode, the clock signal will be always equal to 0, so that it makes the PMOS transistor on and NMOS transistor on as a off state. Similarly, in the evaluate mode, when the clock turns equal to 1, the PMOS transistor switch off and makes the NMOS transistor switch on. So this is the case for the two different modes of operation. Coming to the foot part. So in case, just imagine if in the foot part NMOS transistor is not there. So when during the pre-charge mode, that is when PMOS transistor is equal to on, there is possibility, based on the input variable, there is possibility of every output flowing towards the ground. So that is why we need the foot with the help of NMOS transistor here. So here is the basic structure, basic dynamic logic structure as discussed in the previous slide. The Mn is nothing but the PMOS transistor with clock signal phi, and the same clock signal is given to the NMOS transistor connected below the pull down network, and the transistor is represented as a Me. So here in the pull down network we are connecting the inputs, and in between the PMOS transistor and the pull down network we are finding the output of this dynamic logic circuit. So this is the basic structure. So with the help of this structure we can design whatever logic circuits based on the given Boolean expression. So this makes number of transistors less, and then make the cascading or make the complex circuit much simple when comparing to the static logic. So this is the time for activity. And coming to this slide, we are seeing the comparison of CMOS circuits with, that is static CMOS circuits with the dynamic circuit. See, we are taking an example as inverter. First example, that is nothing but a static CMOS circuit. We are having one PMOS and one NMOS. And coming to the pseudo NMOS, we are having the PMOS in the pull-up network, that is grounded with the gate terminal, and we are having the NMOS as usual with the input signal. And similarly, coming to the dynamic logic, we are having the same clock signal that is given to the pull up network, and in the pull down network we are giving the input as A. So this is the case here. So with this small introduction we can close this video, so we can see in the next video about the advantages and disadvantages of this dynamic logic circuit. Thank you.